Good morning, everybody. So after a long time, we are joining with the live session. We had two weeks break, no? Okay. So today our plan is to continue Python programming. So we did file handling as well as data structures. So today we are going to discuss the sorting algorithms. Okay. Most of the time, I only discussed up to file handling, right? So this time I decided to discuss sorting algorithm as well as some other topics, at least in introductory level. Okay, because in the university, definitely you have to learn some sorting algorithms and some other topics. So I'm not discussing always. I'm not discussing all the things, right? Therefore, so what I want to give you is just the basic we call foundation. But now we have very far away from the foundation level. Anyway, I want to introduce some other topics. So you will remember we discussed commonly used algorithms. You can remember in practical number 9 or 10, we discussed commonly used algorithms, some algorithm, then average, product algorithm, minimum, maximum, and sorting. Sorting other common data manipulations or data processing algorithms. They are the common data processing algorithms. So if you remember, right? Uh, so I'm going to create a list, right? Let's say L with several numbers 12, 56, 45, 11, and 9. So I want to find the maximum of the list. So one of the method that I can use is I can use max function. Okay, by using max function, it is possible to find the maximum. So I'm going to run this program. The maximum is 45, even though there are two 45s, maximum is 45. So if you are doing this without using max function, I think you can remember it or you can understand it. Normally when we finding the maximum, we consider first element or the first number as the maximum. Let's say I'm going to use m for maximum. So I can consider first element as the maximum, right? Then I can go through all the elements, right? And what I'm going to discuss is the maximum. Maximum එකෙන් පටන් ගන්න හදන්නේ මේක ඔයාලා දන්න එක. Maximum. This is by using max function. Method 1, max function. By using max function. Method 2, without using max function. So we can I in range 1 to length of the list. Okay, if li makar එක I එකක්, m0 is also is greater than 1, but greater than m, මොකද වෙන්නේ ඕන then m equals li. ඒක හැමෝටම මතකයිනේ මේ විදිහට කරන්නේ. I in range. See, the 99 is the maximum. මේකෙන් අපි පටන් ගමුකෝ බලන්න. Because what we are going to discuss today is also type of algorithm. So what we are going to discuss is the sorting algorithm. First we will start with the maximum algorithm, because we did not discuss maximum algorithm related to a data structure. List එකක් වගේ පාවිච්චි කරන්නේ නැතුවනේ අපි කරේ. Right? So because today we are going to discuss sorting. Always sorting is related with data structures. Without a data structure, we cannot discuss sorting and other. We cannot discuss sorting. That's right. Okay, I think this is not an issue, so we can go ahead and discuss. Right, all of you. So sorting means simply arranging data in particular order. Hmm. Let's say an example. Let's say we have 14, 33, 27, 35 and data 35 and 10. So these are the data that we have, we call unsorted data. Okay, unsorted. These are the unsorted data. So once it is sorted, okay, once it is sorted, what we want is sorted data, sorted value. Hmm? Sorting means when there are numbers, the sorting can be ascending order or descending order. When they are, when the data set or numbers, data set of values are words, so we call strings, then we have to consider alphabetical order. Likewise, we can sort by considering various methods. So as these are numbers, so normally in most of the simple situations like this, what we do is we will go through the list. We will go through the list. Now I am going to sort according to the ascending order, R1 filter. So we will go through the list and find the smallest one and put here. And this is done. Then go through the remaining items and find the next lowest value. It's also done. Then scan this and find the lowest value. Lowest value is 33. Lowest value is 27. Okay, 33, 35. So this is one of the possible way of obtaining the sorted list. But practically there are many ways to look at the data set. There are many ways to. So here what I did is this is the original list, original data set. Let's say we are going to place these values into a list. I'm going to put all these numbers into a list. So list is a container or data structure we can use to keep numbers. No, you have 0, 1, 2, 3. So these are the indices. Yeah, indices. Let's say this is L. Then these are the Li values. So in this method, what happened is, so I use the existing list and I scan it and find the minimum value and put it as the first element, put it as the second element. So I created a new list. This is the original list. Original list. This is the new list. created, right? So here a new list is created, right? But in computers, in computer programs, most of the time it is better to use the existing list, the original list, rather than creating a new list. Because if you use a new list, what happens? You have the original list as well as new list. No, that means you are going to use two. You are going to use additional memory space, right? Especially when we are dealing with data handling. Now, these are very common topics these days. How to reduce the number of data that we are, how to reduce the memory space that we are going to use. These are very key topics. You have heard data mining, data security. Therefore, this approach is not practical and all the time. This is one of the simplest methods. We can find the minimum and put it at the beginning. Likewise, we can do it. But in this case, what happens is we have to maintain another list. Therefore, this method is not practical. And the other thing is that uh, when the list size is very large, let's say it is, let's say you have millions of values, not just 5 values like this. Let's say you have millions of numbers. It is difficult to, you have to scan all and find the minimum value, find the next minimum value, and so on. Therefore, it will take more time to scan, right? So these are the some drawbacks that we can't use this kind of method, right? So there are several sorting methods. So I will introduce one of the method that I am familiar. So I was in the school hostel, grade 6 to grade 11. I was in the hostel, right? In our hostel, usually grade 6, grade 7, like this, there are grades. Uh, so for the most of the applications, we have to stay in a queue, right? In the morning, there will be a parent check whether you have properly dressed to go to school. Uh, you have to stay in a line or a queue. When you are going to a meal out of the dining hall, you have to stay grade 6, grade 7, likewise, queues, right? It's a very common situation, right? You have to stay in a queue. Then now on queues nowadays everywhere we have to queue, right? When we go to university, again everything based on queue. In the canteen there's a queue, the library there's a queue, likewise examination hall, always queues are maintained. Then it's easy to operate, right? Let's say this is this queue. Queue again, right? ගොඩක් වෙලාවට අපිට කියන එකක් තමයි, for example, let's say we are going to take a photograph, then we need to arrange according to the height, right? So we need to arrange according to the height. Now බැලුව ගමන් ඔයාලට පේනවා who's the shortest person and who is the tallest person. But normally in our queue we have 40 students. In a batch we have 40 students. So one of the method that we did was, I can remember, because sorting is not a new thing. It is not a new thing. It's not a specific thing for computer science. It's something that we use day-to-day life now, right? So in our case, what we did was, let's say this should be the tallest position should be here and the shortest person should be here. So what we did was, we just two adjacent person. Now the first person and second person, so we have already arranged. So what I have to do is, I have to look at my besides. Let's say this is the shortest side. මේ පැත්තේ ඉන්න එක්කෙනා මට වැඩි අඩුයි නම්, so it's all right. මේ පැත්තේ ඉන්න එක්කෙනා මට වැඩි පාතයි, we will swap these two, right? බලනවා these two okay, but these two need to swap. මෙයාව මෙතෙන්ට දානවා, මෙයාව මෙතෙන්ට දානවා, මෙයාව මෙතෙන්ට දානවා, swap these two. හැමෝම මේ විදිහට බලනවා, මේ දෙන්න බලනවා, they need to swap, right? Likewise, there will be several repetitions. Several repetitions. So finally, ne uzamekkena metenta. Metenta set වෙන metenta. So the shortest person will move into this side, and the tallest person will move into other side, like a bubble. Or a bubble එකක් යට ඉඳලා උඩට එනවා වගේ. Clearly, there will be movement. So this is called bubble sorting. Right? This is called bubble sorting. So what we are going to do is we are going to look at two values next to each other. If they are okay, then we have to we have to put another value. These two are not okay, no? So we have to swap these two. Likewise, we swap two values next to each other. Two values next to each other. So this method is called bubble sort. Queue එකේ ඉන්නකොට ගොඩක් වෙලාවට අපි ඒ දවස්වල ඕක තමයි කරේ. දෙපැත්ත දෙන්න මාරු වෙනවා බලලා. Now as it is a computer program, we have to do this in a particular order. But normally in a queue, what we did was we can simultaneously change. May then change වෙන ගමන් තව දෙන්නෙත් change වෙන්න පුළුවන්. But here what we are going to do is a computer program, and therefore we have to follow a particular linear manner. So first we will check these two. First we'll check these two. These two, okay, no? These two, okay. But we need to change these two. First check these two, they are okay, no? So 14, 32, 27, 35, 10. මේ දෙක තමයි අපි මුලින් check කරේ. Right? Then we will check these two. So they need to swap. එන්න මාරු කරන්න. Okay. Then check these two. These two, okay. These two need to change. Right? Okay. Then check these two. Then check these two. They need to change, no? Therefore change. Doing one scan is sufficient? All of you? Huh? Go through the list at one time. Is it enough? We have to do this several times. Let's say the shortest person, in this case, the shortest person is in this side. No? So if you do one time, only one step will move. So we have to do this at least 5 times. So this method is called bubble sort. This is called bubble sort. Bubble sort. Okay. So that is the first sorting algorithm that we are going to implement today. බලමුද මේක implement කරන්න? Okay. කාලේ පටන් ගන්නකො මාත් එක්කම කරගෙන යන්න. Number 1, bubble sort. Some of you may already familiar with this. මම මේ දන්නේ නැහැ කියලා හිතලා මේ කට්ටියට මේක කියලා දෙන්නේ. If you are already familiar, you can quickly implement. Otherwise, you can try කරන්නකො. So first we will create a list. අපි අර same list එක ගන්න පුළුවන්. මේ list එක ගම මම board එකේ දාපු එක ගමු. ඕන එකක් ගත්ත පස්සේ tute එකේ තිබ්බ එකම තමයි මම ගත්තේ. We have 14, 33, 27, 35 and 10. එකක් තියෙනවා කියලා තමයි මට මේ කියලා දෙන්න ඕන ඉච්චරයි. So at a time, we are going to compare Li. We have to compare Li with Li plus 1. Li plus 1. These are two adjacent values. We have to compare Li with Li plus 1. So I, we need to change I. So for I in range length of L. Length of L minus 1 is okay because we don't want to go to the last element. No. Length of L is, length of L is 5. 5 minus 1 is 4. එතන අපිට මේ 3 වෙනකන් යන්න ඕන. බිඳුවේ ඉඳලා 3ට තමයි යන්න ඕන. 0 to 3 මේක කරා හරි. එතකොට compare Li and Li. Okay. So we can use length of L minus 1. එතකොට ගන්නට 0 to 3 නේ values generate වෙන්නේ එතකොට. අපිට අන්තිම එකට කලින් නවත්තන්න වෙනවනේ මෙතන. We are going to sort in ascending order. Ascending order එකට තමයි බලන්න. Swap කරන්න පුළුවන් මාරු කරන එක simple. Okay. මෙහෙම කරාම යන්නේ එක scan එකයි. I will print the list at the beginning as well as after the first scan. $14.33 not change, $33.27 change, and $33.35 not change. But when we have 35 and 10, we have to change. So like scan එකක් ගිහිල්ලා තියෙනවා. So we have to repeat this. We have to repeat this several times, no? Repeat කරන්න ඕන අවම කියන්නේ දැන් 10 එක කෙලවරේ තියෙන එක තමයි worst case එක. So 1 2 3 4 steps. We have to do at least 4 steps in order to reach the last element as the first one. So that means we have to repeat this code 10 times. මුළු කෝඩ් එකම රිපීට් කරා නම් හරි. එකකට අඩුවෙන් රිපීට් කරා හරි හින්දා මෙතන අපි -1 කියලා දැම්මම the worst case is the lowest value is at the right hand edge. හරි. එතකොට because at one scan the maximum displacement is 1, that's why we need to do L minus 1 length minus 1 steps. දහය ටික මෙහෙට ගිහිල්ලා තියෙන හැටි පේනවනේ. මේකට තමයි එතකොට බබල් සෝට් කියලා කියන්නේ. Okay, we'll see what is insertion sort. Second sorting algorithm that we are going to discuss is the insertion sort algorithm. I can remember this method also. Now, we mentioned the bubble sorting. Let's say you are in a queue, you can apply bubble sorting in order to sort. So such situation, what we did was, we have to do a self-arrangement again. Adjacent, then arrange, self-arrangement, right? But you can think that insertion sort algorithm is a some instructor, not a self method. It's an instructor driven method. Somebody will do this, right? Let's say, think about the previous queue example. Queue එකක් තියෙනවා කියලා හිතන්නකෝද? So in this method, what happens is one of the senior guy will come. අයියා කෙනෙක් වගේ එනවා. So look for you stay here කියලා කියන මුලින්ම මල්ලිය ආයින්න කියලා කියනවා. And the first person is no, we are not initially we are not going to change the first person. Can you understand? පළවෙනියට ඉන්න එක්කෙනා change කරන්න යන්නේ. We are not going to change the first person. Then what we are going to do is we are going to look at the rest of the people. We are going to look at the rest of the people. Actually, these algorithms are closely related. I also can't remember some algorithms sometimes. Therefore, I will check. Insertion sort algorithm. In this place comparison based algorithm, sublist is main lower part when it is to be inserted. Yeah. Okay. So the first guy will look right. Right. Then what happens is look at the second person. Look at the second person, and the second person is compared with the first person. What we compare? When we compare the second person is with first person, they are all right. That means up to this level, let's say only one person, then nothing to do. Then we look at the first two. They are also all right. Okay. Now we have the third person. Now go to the next person, next unsorted person. So these are sorted. These are unsorted. Look at the next first unsorted person. Right? So what is the look at it? I will say Amalli. For this person, we are going to find the suitable location. So what is the suitable location for this guy? What is the suitable position for this guy? Because this part is always sorted. Okay, so we will keep this guy as the first. Malli, you go to the first place. Then Anit Mallila මොකද කරන්න ඕන? ඒ මල්ලිලා shift වෙනවා. ඒ මල්ලිලා ඔක්කොම shift වෙනවා. Right? So this one will be placed, this next person will be placed in the right position. Will be placed in the right position. And all other sorted values will be shifted one. But up to this level, look at, right? So this is the sorted part. Sorted. Sorted list. This is the unsorted. Right? I will explain with this numerical values, then it will be more clear. So this is the initial state, right? We call unsorted. This is the first step. In first step, what we are going to do is we are going to compare these two. These two okay, no? Therefore, no change. Okay. Now after this level, it's all right. Then look at the next guy and find the suitable location for this guy. The suitable location for this guy is this location. එයාට suit කරන තැන මෙතන. So 14, 27, 33, 10, 35, 19, 42, 44. All of you. Now up to this level is sorted. Up to this level is sorted. This part is unsorted one. Always we look at the first unsorted element and find the suitable location. What is the suitable location? The first position. May I unknown in the method. Then after the third iteration, 10 මේ ඔක්කොම shift වෙනවා. මෙන්න මේ set එකම මෙතෙන්ට all the sorted array will be shifted by 1. 10, 14, 27, 33. Okay. 33 ඇවිල්ලා තියෙනවා. 3, then 35, 19, 44, 42. Right. So this is the sorted part. Sorted list. We call sorted sublist. This is the unsorted sublist. You can see there are some. If you are following this method, it is sufficient to go from here to here one side it is sufficient to go from the beginning to end one time. But when you are going here to here one time, you have to struggle and you have to put this element into the right location. මේකට නම් සූට් කරන තැන මෙතනම තමයි. මෙතෙන්ටම එන්නේ. Right? So this one is called key. මේක තමයි අපි මෙයාව තමයි මෙයාට තමයි අපි තැන හැමතිස්සෙම හොයන්නේ. we call key. මෙයාවට අපි හොඳ තැන මෙතෙන්ට බලා ගන්නවා. What is the suitable location for this guy? ඒ ටික shift කරලා. Okay. Then we have to repeat this fold, right? So this is called insertion time because this arrow එකෙන් තමයි අපි දාන්නේ මේ තියෙන insert වෙන්න. This one will be insert somewhere කියන. මේකට අපි සාමාන්‍යයෙන් මේව left කියලා වගේ දාගන්න පුළුවන් අරකට right කියලා වගේ දාගන්න පුළුවන්. එහෙම තමයි අපිට. So how do we do this? So I think better to look at the solution first. The other Mugasella 33, 27, 10, 35, 19, 14, 32, 27, 10, 35, 19, 42, 44. මේක ටිකක් වැඩිපුර තියෙන්න ඕන මේක තේරුම් ගන්න එකයි. විතම දැන් මේ ටික sorted කියලා. මේ ටික තමයි unsorted. Okay, let's say first unsorted location is I. First unsorted location is I. First unsorted location is I. That means Li. So මේ ටික අනිවාර්යයෙන්ම sort වෙලා තියෙනවා. As it's a sorted part, no, it will be sorted. Li එකට අපි මොකක් හරි නමක් දාගමුකෝ key කියලා. Because you have to search key. You have to search the suitable location for Li. You have to find a suitable location for Li, right? If Li is Li less than Li minus 1, so we have to I minus 1 means I minus 1, I minus 2 sorted part. Normally in this case what we use is we use another index j. So j is I minus 1. So we have to use a repetitive structure. Because we have to find the suitable location for key, no? think it is better to share the code like this. One මම මේ කරපු එකක් තියෙන එක share කරන්න. I think it's better. Code එක try කරලා බලන්නකෝ. මම එවල තියෙන code එක. First you can try and try to understand, then it will be clear. I have already shared the code. බලන්න මේ code එක try කරලා බලන්නකෝ. chat එක copy කරන්න බෑනේ මම අර පොඩි setting එකක් එක දවසක් වෙනස් කරා ඒක තාම හදන්න බැරුණා. It is not possible to change that setting while we are in session. better to try this. පොඩක් කරලා බලන්නකෝ. I will explain because these codes are difficult to that we have to understand the algorithm as well as we have to understand the coding for the algorithm. There are two tasks to be done. Now we have identified that we have already understand the algorithm. Therefore, now we have to implement the algorithm, but I didn't give time to implement. So what I mentioned is just look at this code and try to understand. Better to do it in. So data structures and algorithm is a separate subject area, as I mentioned earlier. I learned these algorithms when I was in level two. I think level two. In level two, we had a subject called data structures and algorithm. Okay. But not only these things, we have to discuss a lot. Their complexity, efficiency, like this. There are a lot of things to be discussed. So this is the beginning of the data structures and algorithm. You have to learn it in the university as a separate subject. Right, I'm going to explain the code. I'm going to explain the code, all of you. So at the right, there are some simple rules in this case, right? Always the list is divided into two parts. First part is the sorted part, and the second part is the unsorted part. So initially, all of you, initially we have the first element. No, we have all of you look at the 14. So now we have divided into two lists. First one is the first element is the first part and the other part. As first part is first part or sorted part is one element, it is already sorted, right? Next, what we are going to do is we are going to consider 33. We are going to consider 33. We are going to consider 33. This is called key, no? And we are going to insert 33 in the right location of the sorted part. But now what is the sorted part? Sorted part is just one element 14. No, there is no any location to insert it. So better to keep it in the same location. All of you. Therefore, so up to now, once we done the first step of first scanning, once we done the first scanning, we the first there are two elements in the sorted list. There are two elements in the sorted list. Okay. Next, what we have to do is we have to consider 27, and we have to insert 27 in the right location of the sorted list. I don't know method, so we will insert, and this highlighted part is the sorted list, and we have to continue this. We have to continue this for 35, then 19, 35, 35 then next 19, 42, and 44. So circled element is the element that you are looking for. In other words, it is the key. ඒකට තමයි මේ key කියලා කියන්නේ. හරි මම අපව මේ පැහැදිලි කරන්නේ මොකද්ද මේ කරන්න යන්නේ කියන එක. ඒකට තමයි මේ key එක කියලා කියන්නේ. Key එක. Okay. මේක තමයි key එක. Now you can see that key the index of the key is 1. Index of the key is 1. Index of the key is 1. That's why in the code we are starting from y. We are starting from 1. Can you understand? 0th එක අපිට ගන්න ඕනේ 1 වල ඉඳලා තමයි යන්න ඕනේ. 1 to len minus 1 to length of length එක දැම්මම පස්සේ length එකට එකක් අඩු වෙන්නේ කොහොමද යන්නේ? That means we will move into the 44 right location. Can you understand? That's how the initial for loop is selected. I is from 1 to length of L. Can we circle කරලා තියෙනවා 1 වල ඉඳලා ඒක index එක තියෙන්නේ length of L වෙනකන් තමයි තියෙන්නේ. That's the first thing. Okay. අපි දැන් බලමු මම මේ 35 19 දෙකක් දාලා තියෙන එක. Now look at somewhere here පොඩ්ඩක් මැද තැනක් කියලා අපි හිතමු. Right, let's say now we are here. Okay, look at the third line, and we need to insert 19 into the right position, right? So in the code, all of you, in the code, key is there is a variable called key. Key is used to hold the circled object. According to the step 3, the value of key is 19 now. Value of key is 19. Li. I circle වෙලා තියෙන කෙනේ ith object එක. Key I is 19. J is the element before the current location. Okay. Then මෙතන තමයි I එක. This is I, and this 35 will be J. 35 is J. Okay. 35 එක තමයි J කියලා කියන්නේ. IJ. $19 තමයි I. 35 තමයි J. Okay. So you can see here condition that J is positive. J is positive. That means J cannot be negative. That is one condition. And the other factor that we have to consider is LJ. LJ. LJ means this LJ. LJ කියලා කියන්නේ LJ. So initially this will be the LJ 35. Now key 19 is less than 35. Right? But we have to find the suitable location. LJ. At the same time, what we are going to do is we are going to set Lj plus 1. This is Lj plus 1. Lj plus 1 is this 19. We are going to set Lj plus 1 to Lj. That means this element will come here. 35 will come to the position of 19. We will lose the 19, but we have already keep variable key to hold the 19. Then what we do is we increase the j by 1. J is decreased by 1. Therefore, next time the j and the box box move to this location. J is here now. Therefore, this is Lj now. Okay. Then we compare Lj with key. Again, key is less than Lj now. Therefore, we have to do another step. 33 therefore Lj plus 1 will be Lj, and we will do it. Right? We will do it until this condition is arises. Let's say somewhere this condition is not satisfied. That means Lj less than Lj greater than key is not satisfied. Then what you are going to do is key is equal to Lj plus 1. If you consider next step 27 as Lj, now this condition is false. Condition false. Then what happened is this place is occupied by 19. Right? Definitely we will go out of the while loop and Lj plus 1 is equal to key. Right? So this will repeat for all the values of I from 1 to end of the list. Okay, do you have some idea? So because the algorithm is not a difficult algorithm, anyone can understand the algorithm. So what you have to interested is the implementation. So this code is one of the possible ways of implementing the algorithm. I have used for loop and while loop, but if you want, you can use different methods in order to have a common understanding. I discuss this in this way. ඉතින් ඒ වගේ ගොඩක් ක්‍රම තියෙනවා. Bubble sort, insertion sort. There's another one called selection sort. මොන හරි මේකේ ප්‍රශ්න තියෙනවද? Some of you asking about this line na මෙතන key එක කියන්නේ li කියන එකනේ අපි ගන්න. li තමයි key එක. round කරලා තියෙන එකනේ key එක වෙන්නේ ඒක. At the same time I am going to set j to I minus 1. j කියලා කියන්නේ ඒකට කලින් එකනේ. j වලින් තමයි අපි j එකෙන් තමයි අපි අර sorted list එකේ යන්නේ. ඒකේ j කියලා කියන්නේ sorted list එකේ right most element එක ලොකුම එක. හරි? ඒ ලොකුම එක compare කරලා බලනවා key එකත් එක්ක. ඒතර key එක ඊට වැඩි අඩුයි නම් ඊට පස්සේ ඊළඟ element එකත් එක්ක compare කරලා බලනවා. sorted list එකේ එන්නේ දකුණු පැත්තේ ඉඳලා වැඩි පැත්තේ ඉඳලා වැඩි පැත්තේ ඉඳලා බලනවා. sorted list එකේ වැඩිම එකටත් වැඩිය මෙයාම අඩුයිද කියලා බලනවා. හරි අඩුයි නම් ඊළඟ එකට වැඩි අඩුයි කියලා එහෙම එකින් එකට එනවා. j කියලා කියන්නේ key එකට කලින් එක. ඊට පස්සේ ටික ටික j වල value එක අඩු කරගෙන එනවා. හැබැයි කෙලවරටම එළියට පයින් එකම අඩු කරන්නේ නැහැ while කියලා කියන්නේ ඒකනේ. ඒ වගේම key එක අඩු නම් විතරයි එහෙම කරන්නේ. හරි. දැන් අපි අන්තිමට false වෙනත් මේ කියන්නේ මේ while loop එකෙන් එළියට එනකොට එළියට එන්නේ මෙන්න මේ condition එක false වුණොත් නේ. එතකොට අපි එකක් ඉස්සරහින් තමයි දාන්න ඕනේ. හරි. Okay, then we will look at the selection sort. Okay, so we are moving to the next one. It's called selection sort. Selection sort is the most familiar method for us. Select, insertion, selection. So in selection sort, what we are going to do is, if you compare with the queue example that I mentioned earlier, okay. So we are going to look at the entire queue. We are going to go through the entire queue and find the shortest person of the queue. That means you should know how to find the minimum value. You have to find the shortest value and pick it and put it. Earlier we picked the shortest one and put somewhere here. No? Then the next one here and so on. Then what the problem was, we have to maintain a new list. Can you remember? You can scan this and find the shortest one. And you have to, if you keep it as the first place of a new queue, then you have to maintain a new queue. So what we do is, we are going to scan. We are going to scan. Okay. We are going to scan. So by scanning, we can identify the minimum. This is the minimum. No? This is the minimum. So we are going to put the minimum not in a new location, we are going to put it here. We are going to put this minimum one at the first position, right? And this one here, we are going to swap the minimum value with the first value. Minimum value with the first value. Therefore, 10 will be here, 33, 27, 14, 35, 19, 42, 44. So we are not going to use a new list. We are going to use the existing list now. Therefore, storage is preserved, right? Then now up to here, up to here sorted. Then look at this and find the minimum. What is the minimum? The minimum of this unsorted part, the minimum is 14. So 14, 14, yeah, 14, 14, 14 will be swapped with the first unsorted element, right? Therefore, we have 10, 14, 27, 33, 35, 19, 42, 44. So this part is already sorted. Then look at the minimum. And look at the minimum of this. So this is the minimum. Should be swapped with the first unsorted value. Okay. 10, 14, 19, 33, 35, 27. Right? So at any instant, we have sorted array. Sorted sub list. And this is the unsorted part. Unsorted list. In C language, we use the term array. In Python, we use the term. So this is the minimum. This is the minimum of the unsorted list. Minimum of the unsorted. And it is swapped with the first unsorted item. It is swapped with the first unsorted item. You have to do swapping. You have to do swapping means you have two main challenges. You have to find the minimum. What is important is the location of this minimum. What is important is the location. කොතනද මේ තියෙන්නේ කියන එක තමයි වැදගත් වෙන්නේ. Index of the minimum is the important one. So to find the index of this one, you can use list method. List method වලින් මේක කරන්නත් පුළුවන්. We have to find the minimum. To find the minimum, you can use the min function, right? You have to find the minimum. Then you have to swap. You have to not only minimum, but you have to find the index of the minimum method. You can remember there was a function called index of minimum. Index එක හොයාගන්න. Then that index must be that location, that this minimum value, this value must be swapped with this value. That's the method. So initially, at the beginning, this is the sorted part, right? If you compare with the previous method, all of you, if you compare with the previous method, in the previous method, we started with one element sorted subset. Now we are going to consider with empty unsorted subset. So we have to start from here and come to the last location. That means you have to vary from 0 to length of n minus 1. Length of n minus 1 when I come to -1 as a repetitive. So you have to කලින් නම් කරේ 1 වල ඉඳලා length of n. Now මෙතන ඉඳලා මෙතෙන්ට දැන් යන්න ඕන මෙතනින් පටන් අරගෙන මේ විදිහට finally මෙයාවනේ අපි place කරන්නේ. It will be placed into the right location. Shall we do this? Okay, so if you compare the previous method with this method, previously in the previous method, all of you, in the previous method, we have to find the we have to insert the key to the right location. However, that means we have to find the suitable location, means that you have to do a comparison. Here, unsorted, we are going to sort, or we are going to compare the unsorted. Previously sorted list we used to compare. Now we have to use the unsorted list for the comparison. So for the simplicity, I will use list methods to do the implementation. Later I will explain without using list methods. Okay. List method එකක් දාලා කරමුකෝ. එතකොට easy. Number 3, insert selection sort. For I in range. Length of L minus 1. So initially we have to find the minimum of entire L. That means I to the end of I. Okay. So this is the entire right hand side at the beginning. This is the entire unsorted list. Right? This is the minimum. Let's say it is M. Then we have to find the location of that one. There's a list method now. L dot index M. Let's say that location is J. J is the location of the minimum. So what we have to do is we have to do a swap. Li must be swapped with Lj. I එකයි J එකයි swap කරන්න. I is the first location. J is the location of the maximum. කලින් එකත් අපිට list method වලින් implement කරන්න තිබ්බා. පිස්තුන අපිට දාන්න ඕන වෙන්නේ නැහැ නේද දැන්? Minimum value is 19. So minimum value is 14. So 14 is already we keep here. Set 10. 10 කියලා දාමු. Okay, so minimum is 10. 10 is placed here. Then the next minimum is 14. Now 14 is here. Then we have to put 27. Yeah, 27 done. Then 33. Then 34. 42. 45. Okay, I have implemented this by using list methods for simplicity, but you have to do it in other way also. එහෙම පටන් ගමුකෝ මෙහෙම කරලා බලන්නකෝ. So here I have done it without using functions also. ඒක අර J හොයාගන්න එක maximum එකේ position එක හොයාගන්න එක we can use this kind of code. Without using functions. So J is the location of the maximum element, maximum element of the unsorted part. අරකේම අර function තියෙන line දෙක replace කරලා තියෙන මේ ටික. there's another algorithm that I have put, but I'm not going to discuss it. Huh? You know what are the sorting algorithms? You have some idea? No? The campus skill like about we behind you will be wonder. The university there will be a lot of surprises. Huh? There's another one called merge sort algorithm. Search in addition, there are some other algorithms, right? So these are the common algorithms: bubble, insert, selection, and merge sort. So I wish to discuss next two practicals also. They are very short practicals, no need to spend a lot of time on these things. We can take half an hour to complete all this. Half an hour to complete. But I think it is better to have a short break. I want to change the settings to copy chat එක. So I will log out from the session and I will be log around 10:15. හරි. විනාඩි 15ක break එකක් අරගෙන එන්න. මම අපි close කරලා අප පටන් ගන්නවා ඒකයි. හරි. Okay.